We'll do some numericals based on horizontal projectile motion. Okay, we have a question here. The question is saying that a ball rolls off a table with a horizontal speed of 2.0 meter per second. The table is 1.3 meter high. Calculate how far from the table the ball will land. So what I'm going to do is I'm going to first represent the problem in a pictorial manner. Okay, so let's say this is the table, right? And here is the surface. This is the surface. Let's say this is the surface, which means the question says that the table is 1.3 meter high. Let's come back to that. So let's say the point at which the ball leaves the table is somewhere here, right? And the question clearly says that the horizontal speed, please remember it's horizontal speed. So it means it has got some initial horizontal velocity only in the horizontal direction, correct? So that's given to be 2.0 meter per second, right? And yes, there's one more information which I have to mention. The length of the table is given as 1.3 meter high. Okay, excellent. Now what I'm going to do is I'm going to also define the axis here. Please remember, it's also equally important to define the axis before we even solve the problem here. So I'm going to make this as x-axis and this being positive x, this being negative x, right? I'm going to make this as y-axis, this being positive, this being negative y, and the origin being here, this is 0. Yeah, the ball is at 0,0 position. So which means, so that's, I think we are done with the pictorial representation of the diagram now, right? So the question is asking for what distance. See, if I have to draw the nature by the nature of the journey of the ball, it's going to project horizontally, right? So it's actually going to travel like this, right? Remember the video which we recorded? That's how it's going to travel. So basically, the question is asking for this distance, which I'm going to represent it by the symbol SH. S representing distance here and H representing in the horizontal direction, right? Yeah. So now we know the unknown. The unknown here is in the horizontal direction. Now, as I taught you, as we discussed from the very first beginning, it is actually possible for us to break this two-dimensional motion into two one-dimensional motion, which are happening simultaneously. So to solve the problem as well, we are going to take the same approach. So let's first look at the horizontal motion. So horizontal motion is what? What kind of motion does it undergo in horizontal motion? It's constant or uniform velocity. So which means the speed, it is, I'm representing it with VH. VH here being, H here representing horizontal, V representing the velocity in the horizontal direction. V doesn't make any difference because in the horizontal direction the speed is not going to change. So UV doesn't make any difference. They're both the same. No difference in the speed, no difference in the velocity. So this is given by displacement divided by time taken. That is equal to SH divided by T in terms of symbols. SH Though I told you it is distance, it's since it's happening in only one direction, the distance and the displacement, they will be both equal in magnitude. Right now, the unknown here is, this is the unknown. So if I have to rearrange the formula to find the unknown, I get Bh into T. And from the question, we know that Vh to be 2.0 into meter, 2.0 meter per second. It clearly says it's projected horizontally with 2 meter per second, right? So that's given, right? So this is the equation which I arrive at by applying the horizontal, the concept of horizontal motion. Now, if you see, I don't know the time. I don't know the time it takes to travel that distance in the horizontal direction. And if I find time, I'll be able to find the unknown which I want. So let's go and check whether we can find out time by analyzing the vertical motion. Right. So vertical motion. Now, what kind of motion is happening in the vertical direction? You have constant or uniform acceleration. That's the kind of motion which we have in the vertical direction. Right. So let's quickly list out the knowns in the vertical direction. The initial velocity in the vertical direction. So uv represents u for velocity, initial velocity, v for in the vertical direction. Yes, small v. Please don't confuse small v with final velocity. Yeah, it's suffix. So that's 0 meter per second. Yes, it's very important to understand that there is no initial velocity in the vertical direction. There is only initial velocity in the horizontal direction. Right? Do I know the final velocity in the vertical direction? I don't know that. Now, how about acceleration in the vertical direction? Acceleration in the vertical direction is going to be 9.8, right? Because it's accelerating due to gravity. And since the axis is negative downwards, I can show you here. Since the axis is negative downwards, the acceleration is also going to be negative downwards. 2. How about the final position or displacement? See, when the ball is undergoing this vertical motion, it is displacing itself in the vertical direction. Please remember, I'm talking about the vertical motion now. So in the vertical direction, it's displacing itself by 1.3 meters, but in the negative direction, correct? So SV then becomes minus 1.3 meters. Again, S for displacement and V for vertical direction. Right? Now that I have 3 knowns, the fourth one will automatically be time now. Now, please remember, both these vertical and horizontal motions are happening simultaneously, which means the time here for the horizontal motion should be the same as the time here in the vertical motion. Correct? So that's question mark here. So if I can find the time using these knowns and substitute that time over here, I get my answer. Hope it makes sense. So let's see. So from the knowns and unknowns, you can quickly realize the fact that I can use the equation S is equal to ut plus half at squared. So S here being minus 1.3 equals u here being 0 times t plus half minus 9.8 times t squared. Now, if you solve this, I'm not going to do that. If you solve it, you'll actually get 0.5 seconds. So, which means this time is nothing but the time taken for the ball to undergo this projectile motion. It's basically, it's actually taking 0.5 seconds to move from this point to this point. Please remember, at the end of the day, it is actually undergoing both the vertical and the horizontal motion simultaneously. For the sake of our understanding, we are breaking down it into vertical and horizontal motion. Right? So what I am going to do is, I'm going to just substitute the t substitute, just substitute, t is equal to 0.5 second in equation number 1, which is sh equals 2.0 into 0.5. So which means sh basically becomes 1.0 meters. Which means the ball is going to fall 1 meter away from the table. That's what the answer is. So to quickly summarize, or rather to give you an approach towards solving projectile motion, is to break it down into vertical and horizontal motions. And you should also remember the fact that time is the same for both the vertical and the horizontal motion. Thank you.